Hello and welcome. This is Barrett from the C4 Cyber Club here at Cypress College. And in this video today, we're going to talk about the Security Plus Lab series, analyzing types of web application attacks. And essentially what we're going to be looking at are two of the most common web application attacks as defined by OWASP, and they are located in the OWASP top 10. This is going to be SQL injection and cross-site scripting. And we're going to be using some purposefully vulnerable machines like WebGoat app and the DVWA to practice these. And we'll kind of go over these concepts. So I thought we could start off talking a little bit about OWASP, the Open Web Application Security Project. They have a top 10 list of web application security risks. And these slides you're looking at, just a heads up, they're kind of in beta stage. It's something I've been working on. They're not quite complete yet, but you're getting a little sneak peek here. So here's a quick overview of the top 10 list. And you could see injection is number one here. Whoops. So injection is what we're going to be looking at in the lab here today. So you can see injection flaws such as SQL, NoSQL, OS, and LDAP injection occur when untrusted data is sent to an interpreter as part of a command or query. So we're going to be looking at queries to a database in this lab, and we're going to try and retrieve information that we probably shouldn't be able to retrieve. The attacker's hostile data can trick the interpreter into executing unintended commands or accessing data without proper authorization. So pretty much exactly what I just said there. I'm not going to cover all these other security risks, but you could see them listed here. We have some more cross-site scripting we will touch on as well. So XSS flaws occur when an application includes untrusted data in a new web page without proper validation or escaping, or updates an existing web page with user-supplied data using a browser API that can create HTML or JavaScript. Cross-site scripting allows attackers to execute script in the victim's browser, which can hijack their sessions, deface websites, or redirect the user to other malicious sites. So we're going to look at this in the second part of the lab, and this is why it's important for web apps to validate user input or to possibly disable being able to run scripts. Oftentimes you'll see this, you can maybe run a script in a web form and that could get reflected back to another user, and that can include malicious code. And this, when it says deface websites, a lot of times when you see, these web hacks that are, owned by such and such hacker group, a lot of times that's cross-site scripting, and they're able to actually inject JavaScript code to alter the actual look of the website. Okay, and then we have the final three web app security risks here. I highly recommend you take a look at OWASP.org. They have so much information on their site about all of these different security risks. So it's definitely useful to get a head start and start learning about all of these risks. Okay, so, and I do have some slides up or semi-completed for injection, so I might as well go over these as well. So attack vectors here, almost any source of data can be an injection vector, environment variables, parameters, which is what we're going to look at today, external and internal web services, and all types of users. Injection flaws occur when an attacker can send hostile data to an interpreter. Security weaknesses, injection flaws are very prevalent, particularly in legacy code. They are relatively easy to discover by examining the code. So that's why you don't want an attacker to be able to get their hands on your code very easily. And then you have, vulnerability scanners like Nikto, OWASP Zap, Nessus, things like that. They can actually run scans and find these injection flaws pretty easily. And of course, the impacts of these can be very devastating. Business impact depends on the needs of the application and data, but injection can sometimes lead to complete host takeover, data loss, corruption, disclosure to unauthorized parties, loss of accountability, or also denial of access. And so this image is good. So essentially, you can see here, number one, a hacker identifies the vulnerability, possibly by doing the vulnerability scans that we were just talking about. And then, so they craft inject a malicious SQL query into input data, such as username or password. That malicious code is validated and the command is executed by the database. And this is possible if the code does not have proper input validation. That's a term you'll keep hearing me say, and probably others in the industry. And as you learn, there needs to be proper input validation. And so if there is not, then the attacker is granted access to view and alter records, or potentially act as database administrator. And here's some quick notes on preventing injection. So as you can see here, number one, input validation. That is the best source to stop this. So if the code in the development phase is written with security in mind, that's always the best choice. But of course, you can do other things, static query statement or static code analysis, a principle of least privilege involving maybe the code itself and the database that's running it, code verification. And then you could also run, web app gateways, web application firewalls, SQL driver proxies to hopefully prevent attacks from happening, But like I said, if you have really good input validation, then these things won't be quite as necessary. And here we have some attack scenarios. So we look at scenario one: an application uses untrusted data in the construction of the following vulnerable SQL call. So you can see here we're receiving a query. It's selecting all from accounts where customer ID equals, and so you see these single quotes are very important. This entire line is within these double quotes. So after this single quote, we add a parameter, which is going to be the user input. So that might be like a username or password. And then you can see we add a final single quote to that. Now, this down here is an example of a SQL injection that is malicious. So you see, this is what the user would input: this single quote or single quote one, single quote equals single quote one. So what this is essentially sending to the database is this query here. And then you see this single quote, and then it gets closed with this one. So it's basically sending, okay, blank ID or 1 equals 1. And then it's going to get closed with the final single quote here. And then what this 1 equals 1 represents is that means true. So oftentimes you might be able to get it to send back the very first, if you're using this as a login, for example, it will log you in as the very first user on the top of the database. And who knows, maybe that's the administrator. So that would be an obviously good scenario for an attacker. But so this is just one example. You'll start to see how crafting a SQL injection can become quite an art form and almost a programming language in itself. Understanding SQL and databases is definitely a bonus and plus for this. But I thought that this would be helpful to take a look at this before we dive into the lab, because it can get very confusing for a first time. Okay, so we are back in the lab. First things first, we need to log into the DVL machine. And I will say, when you load this lab yourself, this machine takes a little time to boot up. It takes about a few minutes, but you'll notice we come to this login screen. It doesn't log in to a graphical user interface by default. This is actually running a much older version of Backtrack, which is actually pre-Kali. So it's what Kali was before Kali was Kali. But a reminder on the lab itself on page 6, it will tell you how to log in. Password, or login's root, password's TOOR. And all we have to do is just type in start X to bring up the graphical interface for this. Okay, so we have this up. You see that this is a purposely vulnerable version of Linux, and it's also running, it has an app installed called WebGoat. And this is what we're going to use to practice our SQL injections. So you will come to the menu in the bottom left corner, go to Damn Vulnerable Linux, Training Material, and Web Exploitation, WebGoat, and we will start WebGoat on port 80. So this pops up a terminal window, and essentially all this it's doing here is loading the WebGoat services, and it's also starting a Apache web server for us so that we can open this up in our web browser. Okay, so you can just go ahead and minimize that. You will need to keep it open. And down here, we can launch Firefox from the taskbar. And so we're running this web server local. So we're just going to log into our local loopback IP 127.0.0.1 / attack. I believe this is case sensitive, so make sure that you have that correct. And the login password is just guest. Okay, so you see essentially this is a web app. And this is something that you could even install at home. If you have a VirtualBox setup or a VMware setup, you can download the VirtualBox files and practice this at home as well. But for now in this lab, we will start WebGoat. And we're just going to hop right into injection flaws here in the left-hand menu. And then we will select string SQL injection. Okay. So the nice thing about this WebGoat, there's a lot of information here, so I definitely read through this. SQL injections attacks represent a serious threat to any database-driven site. The methods behind an attack are easy to learn, and the damage caused can range from considerable to complete system compromise, kind of like we were talking about before. It's always good to practice to sanitize all input data, especially data that will be used in OS commands, scripts, and database queries, even if the threat of SQL injection has been prevented in some other manner. And you can see here, it tells us this is what a normal query looks like. So in the lab, it asks us, okay, just type in Smith. Hit go. That is querying the database for the last name Smith. And what it does, it brings back any credit card numbers that are on file for that name. Now, let's try out one of those SQL injection that we were talking about before in the slides. So we do a single quote, and this would be the quote that is next to the enter key. So not the left one that's up by the number 1, but the single quote that's next to the enter key, then space, or 1 = 1 --. And what this dash dash is doing, it's basically saying anything that comes after that, consider it a comment. And because oftentimes what comes after that in a database, it's like hidden information and it won't be displayed. But this dash dash is going to kind of force it to be commented out and hopefully displayed for us once we hit go here. Okay, so congratulations, you have successfully completed this lesson. So you see that we were able to access all of the names in this list. Because we were basically saying we entered this true statement. And you know, 1 equals 1. And when you think about programming, this is a Boolean statement. So 1 equals 1 is the same as saying or true. So this is why we were able to pull all this information. Okay, so now we move on to stage 1, string SQL injection. So if we select a random name here, we'll go with what's in the lab. We'll say Neville. Just hit login. Okay, it just brings us back to here. So nothing happened as expected. You know, there's no password added. So obviously this should probably just bring you back to the login for you to enter in a correct password. Now, we're going to check out an extension that unfortunately doesn't exist anymore. It's been deprecated. I think because of changes in Firefox, it just no longer works. But essentially what this is like an interception proxy. And you'll come to learn in web app hacking, a very popular way to do this is using a tool called Burp Suite. But essentially what we're going to do, we're going to intercept any traffic that's done on this website. So we can hit, and remember all I did, I just came to tools and this tamper data. Realize I went through that pretty quick. And then once you're in here, start tamper. Now when we go back to the page, we're going to try that again. We'll choose Neville, go to login. And this is going to pop up. Yes, let's continue tampering. Let's say tamper. And so this is where the term interception proxy comes into play, because we essentially intercepted this request. The moment we hit the login button, we sent a request, an HTTP request to the web server. In this case, it's local, but normally this would be sent to, you know, let's say you're trying to log into Gmail, you'd be sending a HTTP request to Gmail, but we intercepted it before it can go any further, and we can actually inject information here. So in the password field, we can inject that SQL injection again. And then when we hit OK, we see it moved in the background here. In the tamper data field, we have, if you scroll up, you'll see the status 200. This is the post. So this is the packet, or the packet of us sending it with that injection in the password field. And you could see, yeah, that's form, data, employee, password in the post data down here. So I'm going to stop tamper. And now you can see we actually have access to all of the employees now. So that essentially allowed us to log in as the administrator. So we can go to Larry Stooge, view profile. We have all this information on them. So you can see how if a web app is not properly, doesn't practice good input sanitation or input validation, Could definitely be very dangerous, and you could have a lot of really important information leak in the hands of attackers. So that is it for the DVL machine. I'm going to go ahead and close Firefox, and we will move over to the Kali machine. I will open Terminal, and like we've done in previous labs, we are going to need to launch our local loopback, because similarly, we're going to run a web application that's purposely vulnerable. So we'll need to start MySQL and the Apache web server. So we can do that by typing ifconfig hello up. Now, if we verify with ifconfig, whoops, my keyboard's sticking, we can see that local loopback is now activated. Remember, that's the IP 127.0.0.1. And we just need to start MySQL database. And then we need to start the Apache 2 service. Okay, so now we are ready to go. We can close Terminal, and I'm going to go and open up the Iceweasel browser. Okay, so we'll go to 127.0.0.1/DVWA login.php. Okay, the username is admin. Password is password. All right. So first up, we will go down to DVWA security. And since this is your first time, we're going to go ahead and bring the security level down to low. So that'll make it a little bit easier for us. Okay. And we'll go to SQL injection. So we're still going to do a couple SQL injections on this web app as well. So here we could just do some tests. Let's check out user ID 0. Okay, nothing comes back. Let's try 1. Okay, user ID 1 is admin. 2 is Gordon Brown. 3 is hackme. Okay. So let's use another form of the always true SQL injection technique. This one's a little bit different. So we'll do a single quote or quote X equals quote X, and we'll leave out that last single quote because remember that gets added to the end of any request you make for a SQL database. So we'll hit submit. So now we see that actually dumped the entire database because it's basically saying just send us anything that meets the requirement of true, or just dump all users per this request. Okay, so now this is a nice part of the lab because you start to really see how crafting a SQL injection statement, like I said, kind of touched on earlier, it almost becomes like an art form, and it's definitely a lot of things to learn, but this is a really good practice to see what's possible out there. Okay, so we'll do 1 = 1 union select null version. So here we're essentially trying to dump the version of this database. Okay, so we got 5.5.38 for the version of MySQL. And if we run that line again, we may be able to glean a little bit more information on the database name instead of the version. Okay, so we know that the database name is DVWA. And now let's see if we can get detailed information on the different schema and all of the different table names. All right. So here, as you scroll down, you start to see we were able to dump all of the different table names. So, this could be very useful in crafting even more SQL injection commands to target a particular table and to get information related to that. Okay, now this one is a long one. Be mindful that you try and type this exactly as it shows here. Syntax is important when crafting these. And here we're essentially trying to dump all column content for the user table. Okay, I think I got that. Okay, so, yep, as we scroll down, we see we have a bit more information about the users. So with the username, we have their passwords. And this, I'm guessing, is probably their session ID, related to their cookie session ID, which we're going to get into that a little bit in this final part of the lab with cross-site scripting. But yeah, this would be super useful in doing session hijacking. You could do things like, assume their session so that you could log in as them, or potentially if you're talking about like a message board or something, you could possibly post as them, and all kinds of malicious stuff with that. Okay, so now we're going to move over to cross-site scripting. So a little bit different. And this is where you'll get into more JavaScript, and learning JavaScript will definitely be useful in the future if this is a path you want to go down. You don't need to become like a pro at it, but it's definitely useful. But don't worry, you don't need to be a pro at it at all for this lab. So this is a general web form, sign my guest book. So for name, let's just say XSS1. That part isn't necessarily important. But here, essentially, if you're doing any JavaScript, it's all in between these two script tags, right? So we're going to say script, and this is just going to be a general alert. So this will be like a pop-up box. Exploiting XSS vulnerability test. So anything in this quote, that's what's going to display inside the pop-up box. And then we need to close this out with a ending script bracket here. Okay, so we'll sign guest book. Okay, so we got the pop-up. So what this means, if I were doing penetration testing on this website, maybe I was doing a bug bounty, that is not a malicious code. That's just a general alert pop-up. But this would tell you that cross-site scripting is possible here because I was able to run a very basic script. So this part in between this alert, this is where a malicious script would go. And you can see how dangerous this is, because if this is a public guestbook on a public website and an unsuspecting user visits that website, that malicious code is going to run as they visit it. So this is where it can be very dangerous for other users visiting the website. Okay, so let's go ahead and reset. We'll go to setup here, reset the database. Okay, then we're going to go back to XSS stored. And now let's try embedding a website into this guestbook. So we'll just call the name for iframe1. Once again, the name isn't necessarily important, but here we will say iframe src equals, and let's just do the address of our local loopback site, basically the standard site for our web server that we're running on our own local machine. Close that out, assign guestbook, and now here you see down here, this is just kind of like the default site that runs on the web server. So this is another way that attackers can inject malicious content into a website. Okay, we'll go ahead and reset one more time. And we'll head back to XSS stored. And now here, finally, this is the last part of the lab. We're going to talk about that cookie that I was talking about. So we could potentially grab cookie information through cross-site scripting as well. And we could even pull this up in a pop-up alert. Okay, so you can see here, this is the session ID for our current, login for here. So, and like I said, this is very similar to what we saw above when we dumped all of that column data from the user list. So we were actually looking at specific user session IDs. Great, so that completes this lab. Lab 9, analyzing types of web application attacks. Thanks a lot for watching.